Hey guys, welcome back to another RASK maths tutorial, and in this tutorial I'm going to be showing you guys when we flip the signs when working with inequalities. So the short answer is you flip the sign whenever you apply a decreasing function. And this doesn't actually have to be decreasing across its whole domain, but only the domain in which the inequality is sort of valid. So let's have a look at an example. Let's just say we have some random function g of x, and we want to see when this is greater than 5. So we can do this geometrically. I'll make g of x some kind of increasing function like that, and we'll have y equals 5. So these are our points, and if we're trying to find a region where g of x is greater than 5, well, it's obviously just going to be everything past this. So these are our solutions for x. And now, how could we actually solve for that? Well, we might want to use the inverse of g. Or before we actually do that, I'll just explain why you flip the sign whenever you apply a decreasing function. So if you think about it algebraically, let's just say f of x is a decreasing function. What this means is if we have two x coordinates, x2 is greater than x1, f of x2 is going to be less than f of x1. Because if you think about it, some decreasing function, if you have an x coordinate here, this is going to be f of x1, and this is going to be f of x2. Since it's decreasing, gradient is always negative, so f of x2 is obviously going to be smaller than f of x1. That's essentially what a decreasing function means. So if we look at our example from earlier, g of x is greater than 5. In this case, g of x would be x2 and 5 is x1. So if we were to apply f of x to both sides, f of g of x and f of 5, what this tells us, since g of x is the larger x value in this case, it's the output, but it's also getting fed back in, so it's an x value now. F of x2 is going to be less than f of x1. So see how if the inputs are sort of in this order, the left input is greater than the right input, then applying a decreasing function is going to flip it so that the left input is actually now less than the right input, or I should say output. And yeah, that's basically why the sign of an inequality flips whenever you apply a decreasing formula. Now, most of you learn that the sign flips whenever you multiply by -1, but that's actually just a that's just a simplified version of the general rule, flip sign whenever you apply a decreasing formula. Because if you think about it, when you multiply by -1, you're applying the function f of x equals, sorry, not -1, f of x equals minus x to both sides of the equation. And if you plot y equals minus x, this is clearly a decreasing function because f dash of x is equal to -1, which is less than 0. That's why it's decreasing. So yeah, hopefully it's clear why you flip the sign whenever you apply a decreasing function. When you apply an increasing function, then this would actually be the other way around, so both signs stay exactly the same. And hopefully you can see, if this was the other way around, g of x less than 5, then we just make g of x x1 and 5x2 as the two inputs, and then this would just be the other way around, so we would just flip the sign the other way. So yeah, now let's have a look at a few examples. Let's say we're solving the inequality e to the x is greater than 5. Well, what we can do is apply the natural log function to both sides, and the natural log is actually a strictly increasing function. It actually tends towards infinity super slowly, but it does. So we can apply the natural log of both sides, simplify the left side to just get x, and this gives us our final answer, x is greater than 5. So generally when you're working with logs, it's going to keep the sign in the same place, but something interesting happens when we choose a base less than 1. So let's just say this is generally what the graph of any log looks like when, let's just call this y equals log base a of x, where a is greater than 1. If it was 1, then log of a would be technically just always be 1, right? No, it would only be defined when x was 1. But something interesting happens when we choose a log of base less than 1. So if we say log base a of x, where a is less than 1, let's just say between 0 and 1, because we can't have a negative base, then the graph is actually going to look something like this. Whoop. So it becomes a decreasing graph. And the reason for this is because you can actually write this as log base x, let's just say log 10 over log 10 base a, change your base formula. And log 10 of a, if it's less than 1, is actually going to be small, is actually going to be a negative number, because 1 is 10 to the minus 1, and then anything below 1 is just 10 to the minus something smaller than minus 1. So yeah, when the base of a log is less than 1, it's a decreasing function. So therefore, if you had an equation such as 0.5 to the x is equal to, is greater than 3, if you apply log base 0.5 of both sides, then since log base 0.5 is actually going to look like this, a decreasing function, you have to flip the sign. See how I flip the sign? And then from there, it's actually a pretty simple process to solve this. X is just lower than log base, I'll just say a half of 3. Evaluate this using change of base formula. And yeah, that's basically it. So thanks for watching. Hopefully that makes it clear that you only have to flip the sign. You flip the sign whenever you apply a decreasing function in the domain of the integral. Sorry, not the integral, the inequality. Thanks for watching, and I'll see you guys in a future tutorial. Bye.